So welcome to today's research seminar at the Institute for Future Studies with me, Ludwig Beckman, and Karim Jabari. And today's guests are three researchers that will speak about the bot-ADA, predicting the Swedish election using a Bayesian state space model. And the three researchers that we have with us today is Jens Finnäs. He's actually a journalist and the founder of Sweden's first freelance agency specialized in data-driven journalism and part of the J++ network. Is that right?
Yes.
And we have Jonas Wallin, Lund University, and PhD in statistics.
And docent.
And Måns Magnusson, assistant professor in statistics at Uppsala University, also previously from Linköping University. We're looking forward to know what the outcome will be on this fall's election in Sweden. That's what we hope to learn about today. And we will have a presentation by the three of you for about 45 minutes. And the sort of outline is as usual here that you're welcome to make clarificatory questions during the talk, either by signaling that in the chat function on internet or by pointing your finger, raising your finger here in the room. And then we will follow up with a Q&A session after the talk. So most welcome to Måns, Magnus, and Jonas. Måns, Jens, and Jonas, sorry.
Thank you. So I'm representing the non-academic side of the team here. I'll say just a few words about the project as a whole, and then Måns and Jonas will get into the nitty-gritty of the statistics. Election forecasting, I would say, became something of a thing about 10 years ago with this guy that might be familiar to a lot of you. Nate Silver, at the time working at the New York Times, made election forecasting a thing when he was able to correctly call the results of I think both the 2008 and 2012 US elections. And it was about the same time that I first came in touch with Måns. I was at the time, just as now, a journalist. As a journalist, I've always sort of wanted to understand and make sense of society through data. That's what data journalism is for me. And I was extremely inspired by Nate Silver and his like analytical approach to election coverage. So I remember meeting Måns at a party, sort of describing my fascination with the work of 538, and Måns said more or less like, well, we could do that as well. That doesn't sound so hard. So we did actually already in 2014 a project that we call bot-ADA, which was an attempt to sort of, in the spirit and methods of Nate Silver, predict election results based on polling data. And that's what we are doing this year again. We recently relaunched our own site, bot-ADA Polopolls, and actually just yesterday we were able to announce a partnership with Svenska Dagbladet going into the elections. So we'll be collaborating with Svenska Dagbladet to give you all the best possible answer to the question who will win the election. So, but I'm going to be a little bit contradictory here. We started the presentation asking who will win the election, but is it even possible to know who will win the election? By looking at maps like these, it gives sort of the impression that it is possible to predict elections, but despite the headline of this presentation, we are going to argue that it's not possible to know who's going to win the election, and that's not really the purpose of the whole project either. I would say that it's actually, and I can almost sort of blame myself that it's a slightly poorly framed question, because really the question that I would say that we are trying to answer is what's within the realm of possibility of outcomes in the election. So not exactly how many percent of the votes are the Sweden Democrats going to get, but what's sort of even possible. And here's another famous example from Nate Silver and 538. He got a lot of critique in the next election, 2016, when 538 called Hillary Clinton as the favorite over Donald Trump. Many people sort of interpreted this as a clear victory for Hillary. But really, the takeaway from these numbers is we would argue that Hillary Clinton or Donald Trump has a really quite good chance at winning an election with numbers like this going into election night. It's sort of definitely within the realm of possibility that Donald Trump could win with these odds. One way of sort of understanding this probability is to think of it as a deck of cards. And if you draw a random card, Hillary would have won with any number ace to 9, and Trump would have won any card 10 or higher. And that's obviously far from certain. So in one way, I see like this whole project being about trying to explain what's possible, what's realistic, and maybe more importantly, what's not. Here's another example from another country where I think it would have been made sense to look more closely at these kind of election models or forecast models. I remember following the French elections, just like the news coverage, I at least got the impression that it was a pretty close race, that Le Pen was increasing in the polls and the margins were getting closer, and that the race was pretty competitive. But if you actually looked at the here's the election forecast of The Economist, the numbers were pretty clear. It was not impossible, but it was certainly highly unlikely that Le Pen was going to win that election. Going back to the deck of cards, these were sort of the odds of Le Pen. And I think here's like what I'm hoping to be an important addition to the election coverage of Botanada is to give some answers about what are the realistic coalition alternatives in the election outcomes. What's possible and what's not, and hopefully that kind of information can help us to have an informed debate about possible government coalitions. So, who will win the next Swedish election? These are the odds that we present today, and just as a caveat, the model today actually is not a forecast model, but it's a model that answers the question: what would the result be if we had elections today? And our best guess is that the left bloc with Magdalena Andersson would have a 58% chance of winning if we had elections today. And going back to the deck of cards, these are sort of the odds that Magdalena Andersson would have going into an election night today. The other maybe key question that we will be following in the next 3 months is the small party Liberalerna and Miljöpartiet. How are those faring? the model today gives both parties rather poor odds of making it past the 4% threshold. But these are also odds that will look slightly different when we start to do predictions on the actual election results. But I think these are really like the two key questions that we will look closely at in the next couple of months. How the odds for both the balance between the left and the right block, how that will shift, and how the two small parties, how they're gonna fare. But that's sort of my small introduction. I'll pass on to Jonas now to get much deeper into the details about what's happening under the hood when we do these predictions and these calculations. How does this work? Jonas, do you want to continue?
Yep, thanks. So I will jump from the imaginary title that I presented. That was not the title that we gave, so I'll just leave that. And since we're already introduced, that's no problem. So this is joint work with me and Jens and Måns, and in particular the model building is me and Måns. And validation is a bit more Jens, seeing if our results are totally crazy or not. Then he's a bit responsible. So I will try to do this non-technical, what's going on in a non-technical way as much as I can, and we'll see how it goes. But basically, what we're trying to do with this statistical model is we're trying to get a distribution of things we don't know, in particular if we're looking for who's going to win the election, of future events, using the past. And the past then is the data. What we're not trying to do is find sort of a magical pattern of some unknown covariates, sort of what's the weather gonna be on the election, what's the result in some small village that typically gives the election results. This is not what we're trying to do. Nothing wrong with that, although I have my doubts. But we're rather trying to see, if we look in the past, how much has party sizes changed? What's the relation between party sizes and how the polls has been? What in a month, how much can a party historically have it changed? Is it possible that the party can go from 10 to 40% or vice versa? And using this to build a model so that we can understand what is the possible or likely and unlikely events, both for polls and the actual elections. And the framework we're using is a box approach, named after the famous statistician George Box, which we work in iteration. So first we build a statistical model. I'll go more details into every step here. And then we have some data, whatever data we can get hold of. And then we try to fit our parameters, our model, to this data. That's the inference part here, if you can see. And then we criticize our own model and see, okay, how well did it do? Was it able to predict previous elections? If you're a regression person, how high is the R squared? Is the model useful, or is it just junk? And then typically it is just junk, so we go back and redo our model, how to change things, and we do inference again, and we loop around this until we get something that we feel is satisfactory. And then we try to apply the model to answer questions like, where do we believe if it was an election today, like Jens presented, and also what will be a likely outcome in the future of the election. And I won't give much detail, but we're using a Bayesian approach, which means that we put the distribution of our unknown parameters that we denote theta. And we like to find a distribution, not a point estimate, of given our data, what is the parameters going to be. So parameters can be anything, as you can see. So let's look how we actually build the model, so the first step. Well, the way I like to think when you build a Bayesian model is that you pretend that you have all the data you want. So we have how the proportion of people that would vote for a party would vote today. Let's denote some party of your favorite, XT. And how did they vote at the previous time point? So this could be a week ago. How much can it change? Well, our best guess, since we don't know exactly how the dynamics work, is just to say, well, it was the same as last week. That's the most likely value. And we do this by imposing that the expectation should be the previous value. But, of course, it's not a deterministic, it's not always the same. So we need some variability. But also this, we have no sort of mechanistic understanding how people move between parties. So we just say, well, it follows a normal distribution, basically. Sometimes it's a bit above, sometimes it's a bit below. And how much it varies, we have this parameter, sigma squared there. Okay. The second thing we want to know is we want to see how does poll behaves if we knew how big a party actually is. Well, if we know how many people were pulled in the poll, and we know that they were uniformly sampled from the true population, then we know actually the true distribution of how many that would vote for a given party. And not vote, but say that they voted in a poll. And that's YT. And that actually follows a binomial distribution. This we would know a little better under these uncertainties. Okay, so we now sort of set up a very toy model with some pretend data and some real data. Because we actually have the polls, and we have the size of the polls, but we don't actually know the size of the party at a given time. And we don't know how much it varies between time. So what we then do is we use this Bayesian model to say that these are our parameters, our unknowns. We don't know the population, party size, etc. But we actually know the polls. So given this data that we know, what can we say about the parameters? And it's very important to stress that this is not the truth. It's our approximation of the truth. And something that Box also said, good to remember, is that all models are wrong and some are useful. But going into the second step, what data do we actually have? Well, we're using around 1,500 polls in 2002 and the elections up to that time. We also have in a different part of the model that I will describe later, the SEB polls and the election times from 1973. But an important question is, we have this data, but how much data do we have? Well, the answer to that is it very much depends. If we want to answer something about the dynamics of the polls, how they can behave, we have a lot of data. We have a lot of polls. But if there is something that is, say, specific for the election, we have very little data. We basically have 5 time points. So if we want to see that something is there a difference between the polls and the elections, we actually only have these 5 time points. And that's the fundamental problem that's very hard to come by, that we'll come back to, is that we only have these few data points. Okay. So then we have our model, we have our data, then we just apply it. This integral is intended to be complicated, and you should not try to understand it because I don't think it's real, but it's how it works. Basically, if you're a Bayesian, you're solving this incredibly complicated integral, but don't worry, nobody knows how to solve it either, even though some people might pretend they do. But what we do is we make an approximation, and in fact, we're using something known as Markov chain Monte Carlo using Stan software. I won't go to any other details, but say this is what we do. This is how we make our inference. If you have questions about this, just ask me or Måns, but it's a bit too technical for here. But that's what we do. So now it's transparent. Okay. Now we have our model, we have our data, we somehow magically get our distributions of our parameters. How do we do? Well, what we do is we look at how did we do at previous results, previous elections. So if we have our model and we had data up to 1 month earlier than election, how well did we fare in 2014? How well did we fare in 2018 election? and the same thing a day from the election. Were we able to predict the election reasonable then? If you have several models, this can also be an opportunity to rank them, etc. We can but have not yet done is prediction on how well we can predict polls, individual polls. This is because it's sort of second nature, because the truth, what we're interested in, is actually how people would vote, not the polls. It's something that we should do that will give us a bit understanding if our model is correct or not, but it's not the main focus. Once we're satisfied with this model and this, so that our evaluation is good enough, it's sort of our benchmark. We have sort of said, okay, we can at least predict this well, so now we somewhat believe what the models say. Then we try to answer questions like Jens discussed earlier, sort of. What is the probability that the Green Party is over 4% at the day of election, or if it was an election today? And this is again an integral. But this is sort of the final step when we're satisfied with all the other steps. Data we can't do much about. Okay. So what is the model in further details that we actually use? And here I'm going to start with describing the model of how a party evolves over time, or our simplistic model of that, and then how we connect it to data. So always X is the state of the actual party, and it could be any party you like, and Y is the result of a given poll. So what you see here, dots here, are simulated data of polls here, and then using these polls, we're taking the posterior mean here in red. And basically what we have is an interplay that the polls pull the data towards the points, but then we look at how historically much has the party changed, then we pull it back to the previous value here. So there is sort of a fight between what the poll says and what the history say. And this is what we try to do in this simple state space model. Even further detail, we assume a normal distribution with some variability. And if you don't know what that is, assume that at time point 0 here, we are at the value 30, which you probably can't see because the labels are too small. Then at time point 1, where the most likely value is given by this bell curve here, the highest point. But any other value between here are rather likely, and the further out you get in the tails, the more unlikely the value becomes. And if we look at small time periods, this can be a reasonable model. So if I look at what are the state of the Social Democrats today, or this week, and then I go to next week, well, most likely it will be the same number of people that would have voted for them now. But some variability. But this is our best guess. But if you go further back in the future, so let's say a month or two, this approximation starts to break down because we don't understand the real dynamics of this. And in long term, it will break down. In a year, it will be very unrealistic. And we will deal with that later. But as a small scale, it can be rather good. Here's another illustration that might be easier to see, that we generated a small process here. Every process, each trajectory here is a process. Each start from this point, then it goes here, and the end points here represents this bell curve. So we see a lot of the trajectories end up here, a few end up here. So that is what the bell curve is measuring. Okay, so, and this is basically, if we go beyond not the election, but just sort of where are the polls today, what we actually say about the dynamics of how the parties vary. So we have a very simplistic model there, I would say. But we also don't have very little knowledge. Where we contribute more, in our opinion, is actually how is the relation between the size of the party and the polls. And basically, in a regular state space model, this just means that if I do a poll today, the most likely outcome of how big of a proportion would answer the poll will be equal to the size of the true population. And then you have a variability that decreases with how many people you ask. If you ask 10 persons, you have a lot of variability. If you have 10,000 persons, you will be rather sure of the proportions. Unfortunately, it appears that there is a lot of issues here that one needs to handle delicately in order to understand this relation. And this is, we handle with two different terms. We have a mean term here, which shifts the poll result away from the true size, from the population true size. So it's a bias term. It's something that makes the polls wrong on average. And in particular, we have a house-specific bias, so a polling institute-specific bias that I will go into more detail soon. And we also have a bias for all the polls together. And both those components are crucial in order to understand what is the relation between the polls and what is the and the population proportion that works for a party. And that.
Could you explain that again? What is industry bias?
Yeah, I'm gonna go into detail on both of them, so I'm just trying to put them here. So it's better if I do it with the slides. No, of course. And then we have variability that I will not talk to, but we have a specific weighting on each house, and we're also looking how many people participated in the polls. But the bias. So we're gonna start with house bias in particular. So if we look here for the Swedish Democrats between 2015 and 2019, we can see that there is and I should say the dots are the polls, and the line is where we think actually the actual true population that vote size that would have voted for the Swedish Democrat if it were election today. If we look here, we see that certain polls, and these are the same polls, lie here under, and some polls are way off and much larger. So we see that these polls here overestimated and made two sort of had a very high bias in favor of the Swedish Democrats. And some might have the under bias, but this is how it works. So that's the house-specific bias. And if you don't adjust for this, these measurements will destroy your predictions. The industry bias is that all parties were polls were wrong. So if you look here at the election date, here is the result of the election 2014, and here are all the polls. And you see that if I take an average, it's not that some were under, some were over, they were all under. So this causes a bias that cannot be helped by just adding more and more polls. It's an industry bias. It's joint for all the poll institutes. So these are the two biases that we address. I'm sure there's more. And in fact, we are actually allowing the house bias to vary, of course, between house, but we also have an individual bias for each house and each party. And further, it varies between election periods. So if we look at the latest prediction where the election period is, here is the expectation of the bias. There is a large uncertainty here. But for instance, some things are interesting. We see, for instance, YouGov that we use have a huge bias in favor of the Swedish Democrats. So if they are above 4% bigger than we think they should be on an average. Whereas the Social Democrats are -2, so they are unfavored in this poll. Something interesting is SSB has an inverted relation that it favors the Social Democrats historically, but pulls down the Swedish Democrats. And if you average over all the polls, over all the blocks, you see a 1% favor approximately for left wing for SEB. But these are, I should say, also very uncertain numbers. What we further did, as we said, is that we allow these bias to vary over time, in particular over election period. So here on the scale is election periods. Should actually be just lines here because we don't have a continuous function. But we say that for each period, the bias of the house changes a bit. So what you see here is the bias and our uncertainty, confidence bound, of the bias in the SEB elections on the current model for the Social Democrats. What you see here is that these are the 90% confidence bands. So, for instance, in this election period, which I forget which this is, we believe that they have a bias somewhere between 2.5 and 1.5% in favor of the Social Democrats. And then in order to make sort of predictions from the future or sort of propagate, we actually use a similar model as we did for the party sizes. So we just assume that each year or each election period, the most likely outcome of the bias is the same as the previous year. And then some variability that we don't know, so we let the data try to answer that for us. So we just add another parameter and try to learn this. Okay, and then we're going to come into this industry bias, how we do that. Well, what we do is that we add another term that is joint for all the houses or all the polling institutes. And we allow also this to vary for each party and each election period. But here the crucial thing is that this is very dependent on information in the actual election, because we have no information other than the difference between how the average of the houses went and the election. So we basically have 5 observations, you can say, oversimplified, for this data. So we have very little data, but once we have seen the election, we kind of know what the bias was. Like once you see here the election result, we know very well that, yeah, somewhere around a few percent is the bias. But before we see the election, like here, what is the bias here? Well, we won't know until the election. So it's a very hard parameter to point down. And this is what you can see here, that we're rather certain once the election is done, but when there is no election, we're very uncertain. But what we can see in the past is that there is a large variability between the years. So at least there has been a strong industry bias all the time for instance, these Swedish Democrats. So here we actually have no idea where the bias is going to be this year. So this gives you, even if you are at the election day and you get the result for the Swedish Democrat from all the polls on election day, you will still have a large uncertainty what's going to happen. Now, this is actually interesting also if you're not interested in predictions. Yes? Oh.
Is the bias also that high for exit polls?
Yeah, I haven't looked at all exit polls, but you can see the same kind of bias in the exit poll. I remember that the left-wing party, for example, in the last election was one example that was overestimated as well. So you see it in the. I haven't checked exactly the same.
It's interesting because in the literature about it, the exit poll should be much less biased. Yeah.
I mean, it's closer to the election, exactly. But I mean, and that's an indication that we have some kind of measurement errors going on.
It's post, no? I mean, the people have voted. They come out of the polling station.
Yeah, exactly.
And then you ask them, what did they do? The other one is, they might still change their opinion.
Yeah, but you still have the same difference, right? In this exit poll, and that indicates that there is some kind of I don't know what it is, but I would guess that there's some kind of non-response bias that comes in when people respond in these exit polls.
Okay, super.
Yeah, but it's a good point that this is something like theoretically we can't know if it is that people change their mind very rapidly, and this is what's causing the difference, or if there is a bias. I mean, if you just go say that, okay, people change their mind every second, then of course we will not be able to separate these two. So it's more of a, we can all, like you say, exit polls are interesting in that sense because that's after the election, so they can't change their mind. They can still lie or not answer, but it's a good point. But what I want to say, about this is you get interesting results if you want, for the research perspective, look at how big were the parties back in time. So if you look here at the left-wing parties, and the dashed line here is the average of the polls done. Do you know exactly how this one is done? It's just average?
I think it's like mostly an average.
You can see that our model predicts a very different trajectory of the left-wing party compared to this averaging of the polls. And the reason is we believe that there was a large industry bias between these periods. So we don't believe that this sudden shift, that people all of a sudden changed their mind here and went down and didn't vote, but rather that there was a bias over all the polls over time. So it rather was a slow, it didn't increase as much here as it did this. Of course, unfortunately, we'll not know the answer, but it's interesting to know that at least this is a possible event. And personally, I have a hard time to believe that than this, but that's just my opinion and should not matter that much. Anyways, but if we then go to this, we also have the issue with the future is rather uncertain. So we need something, we want something else to tie down our model with the, with this, that we have this unrealistic, as I said, simplification of how the parties change over time, or party sizes change. And what we do is we borrow from this Linzer article, where we basically do a simple regression model on the election time using various covariates. I don't recall what he used. He used if there was a wartime.
Yeah, it's called. Sorry, I think it's called the bread and war model or something like that. That is commonly used in the US setting.
And basically he has the same setup. He has this state space model here going here and here, and then it would blow up and be hugely uncertain there. But since he has this regression model, it points down to this. But as you get closer to the election, more inputs are coming from the polls rather than this regression. And we do a sort of similar thing here with a regression model on how the election is going to go this year, using as an offset the previous election, an intercept, and just how the SEB measurement went compared to the previous year, and then a regression. Now something that's important here with this epsilon is that we really need something heavier than just Gaussian or quadratic tails, because if you're familiar with this, we will typically do, if you do OLS regression, you will get something like this. We see is that a lot of the time in the past, there has been many parties that have been rather small in particular at the previous election and even as at the SEB meeting in May, but jumped a lot. So in particular interest nowadays is the liberals. See 2 times between the 70s and now, they jumped from very low percentage to quite high percentage. So we have a very clearly non-Gaussian distribution. And this is sort of how we build our model around the election date.
Sorry, I had a question here, clarificatory question from Henrik Oskarsson, who is with us at the internet, and he asks you whether you have included SCB PSU methods on opinion polls from 1985 and after that has been executed in direct connection to the elections and that were not published after the elections. Is that part of your of your data to judge these in-house your house effects?
No, we have only used the SEB May.
All right.
Opinion polls.
Okay.
Or essentially all SEB opinion polls from 2002 until today, but not these internal ones.
All right. Hope Henrik is satisfied with that.
Okay. And this basically gives you the distribution of this regression model on how the parties look. This is an older version, but it remains still true that we have a quite large uncertainty on what's going to be the election results for all the parties. But just help to calibrate in the other model into the past. Okay, so the final thing I want to talk about is the evaluation. So how did our model do? 1 month out and 1 day out in 2014 and 2018 election. And the dots here you see are the polls, and the red lines indicates the uncertainty of our model. So we see here interesting that this is 2000. Actually, I don't have. This is the 2018 election, 1 month out. We do fairly well, and then we look what we have 1 day out. And then we actually are quite off. You can see here is the election result, here is our confidence band, and our model sort of agrees with the polls that they should end up here, but they end up here. So this is an indication that we actually did better a month out than a day out. But this is something that we think is sort of due to this industry bias. You see here that all the polls are stable around here, and then it changed here. But going back to the previous comment, we theoretically don't know if it was just the polls were correct, and then all of a sudden everybody changed their mind and eventually voted for Social Democrats anyways. We can't separate these two theoretical events out, but the effect will be the same. Because if you can change that much on the day of the election, we don't know, then the polls do not have very little predictive power anyways. And how do we try to quantify this? Well, we look at how likely in our model is it to have this result or something more unlikely, or less unlikely. So what's the probability that our model is at the level of the election or below? And what we see here is that this is a rather poor event, because with 97% chance, we said that the result should be below that. Whereas if we compare here it's only 70% chance that we are that or below, which is fairly reasonable. But this actually, the advantage with this, we get this for all parties, is that we can quantify and know how poorly we did in the past. Or well, depending on whatever, if you're a positive or negative person. But really, if you have a model, this is how we have done in the past, and this gives us an indication how we'll do in the future. Of course, if everything changes and everything is completely unreliable, the past has no predictive power on the future, then obviously we'll do nothing. We'll not know anything, but this is basically what we do for ourselves to say that, is our model reasonable or not? Can we trust any of the questions we try to answer with Jens' results? And this is what we look at. So some final extensions that we want to do. Currently we're treating the parties as independently in the latest run, but we really want joint party dynamics in the X variable, so how big the parties are. So if we want to say that if the Social Democrats fall, it most likely is going to be that the left party is increasing. We have a prototype of this model, but we haven't tested it yet. So this is something we want to incorporate, and we also want to incorporate the data that we quite don't know how to use. Is often in polls you have this second largest party. Which would you go to?
So we actually have the correlation between the parties. I don't know how to technical, but on the eta scale. So we have a correlation. So it's not independent.
Okay, it's not independent.
But it's but we don't measure this dependency between parties explicitly.
No. Yeah. Okay.
We just estimate it based on how the different parties varies together.
And we haven't validated that this is correctly modeled. Something we're looking at also is that we see that around election time, it appears that the polls or the parties actually change suddenly, large jumps or at least fast trajectory changes. We would like to incorporate this in our model. And finally, we also would like to be able to say something about how well are we predicting the individual polls, not how big are the size, but how actually, if there were a poll tomorrow from SEB, what would be the result? Because if then we can validate that and see if we're actually capturing these polls correct, which would give us further strength in believing our model. Of course, we have a separation between polls and election results, but in some sense we are interested in this, although it's a secondary question. And any other suggestions, we're very we don't know everything, we know something. Okay, yeah, that's it for me. Thank you very much.
Thank you. So now welcome to the Q&A session, everyone. And here comes a few instructions. So note that the first half hour of this will be recorded. We will use the chat function to run the Q&A. If you wish to ask a question, you should indicate that in the chat. And as we are a mix of researchers from different fields, we ask you to tell us your area of study so we can ensure that we take questions from different disciplines. So write your name and area of study. If there is a question that you want to follow up on, you can write follow-up to, for instance, Ludwig's questions in the chat, and follow-ups are taken before other questions. When it is your turn to ask your question, I will call upon you, and you will then be put in the spotlight so that your video and sound becomes available to the audience. You can then ask your question. So Karim will collect questions from the audience here and from the from people joining us at Starlight. But I can begin first with one question, and that's something that I'm just curious about. What is sort of your basic motivation? What is your ultimate aim of this project? What are you looking for? What do you want to achieve by developing this bot and by developing this way of predicting or forecasting or elections?
I will let Måns answer first, and then I will say my own motivation.
Yeah, sure. I mean, to me, this is inspired by my research, where I'm mainly interested in trying to measure these latent states or the party affiliations over time, essentially. And the reason for that is that I do a lot of research together with sociologists and also historians, but I think they are less interested in this, and trying to see how we can look at correlations between the party affiliations or the party the opinions, essentially, and other aspects that we find interesting in those projects. And one of my main research areas is also text analysis. So to me, it's really interesting to see if we can combine textual data like the public discourses and how those are related to public opinion. So that's like the driving motivation for me behind this, by developing these models. And then I'm a geek, so I find this super interesting. What can you say about the future when it comes to probabilistic models, essentially? How can you construct a good probabilistic model to say something about the future? So I think that is super interesting. And I'm also very interested in like survey methodology. So how can we quantify these errors that we find? And when we started this project, I actually didn't know that much about this industry bias. I mean, that's something that we have started to see when we started to build these models. So for me, it's those three different areas of research that makes me interested in this.
Yeah, I mean, basically the same, and also sort of putting out a framework that this can be done and with statistical methods. And our model in no ways is complete, but we try to be as open and transparent. We have all code and all data available so that people do not just throw predictions out, that you actually need to sort of say, okay, I predict that it's 5% tomorrow with the Swedish Democrat or whatever. I really want some, like, that there is a proper benchmark and that you sort of hold accountable for what you do, but I don't want to be held accountable myself, but I mean, sort of just trying to get it to an upper level. That's sort of an interest, but mainly also trying to understand the dynamics, what's going on, and I definitely do not do that at the moment.
So I understand that one of your interests is political behavior in a sense. I mean, to understand why parties and voters change and how we can understand that better. But the other purpose is to refine these statistical models in itself. That's purpose in itself. But
yes.
But I guess since you're also now sort of publicizing this in journals and you go public with it, I also imagine that you have some interest in applying this model and what do you think about that? How will it help us? What are takeaways for the public, or for political scientists or for politicians? What can we use your model for?
I haven't thought so much about that, to be honest. I mean, to me, what I think is what has been driving in doing this more publicly is that as a statistician, for me, uncertainty is kind of crucial, right? That a lot of these polls have a lot of errors in them, and I think it's important for everyone to know that, you know, there is a lot of uncertainty when it comes to, you know, the voters, you know, the outcomes essentially. So for me, that is what drive me as a statistician, to just show this uncertainty, and also show that this is, as Jonas was talking a little bit about. I mean, also try to take a first step on this type of models, because Jonas didn't talk so much about that, but recently there have come up much new tools that enables us to build these more complex and better models essentially. So I think that's the driving force for me, at least. I think maybe a little bit boring to just try to put out the uncertainty there, but I think that is an important aspect.
Yeah. No, I don't have much to add, more than sort of building these models and trying to validate is what we do as statisticians, and that sort of is largely the goal on itself. That's basically it.
Yeah, thank you. So, do I have questions from anyone in the audience? We have Joseph.
Yeah, thank you so much. I was wondering, maybe I did not get it, but what do you do with non-voters or turnout in general?
So I don't remember exactly, but I think so. So what we do is that we do the connection. I mean, because in each poll you also have other parties. So we try to map it so it's on the same scale as as in the polls essentially. So it's essentially the election result, so to say, and not the number of what do you say, mandat? Seats in the parliament. So it's on the same.
Yeah, but maybe take a second look at it. I mean, because this really is what is often criticized to be wrong in the polling models.
The estimation of others.
The estimation, and they don't really have a clue about it and how they move, and they don't have the right questions for it and so on. So how highly the probability is that you will not turn out.
Okay. Yeah.
Yeah.
So this could be something about the industry bias, no? So
Yes.
Yeah, that could be something about the industry bias.
There's at least the discussion in the more empirical and opinion-based political science literature at the moment. And then I would like to know, I mean, the 17.6%. So can we bet on this? How secure will this be?
Yeah, I mean that's what we try to evaluate as much as possible, right? So, I mean, formally, I should probably say that I should be able to bet on this model, but I haven't thought so much about it until now. I don't know. What would you bet on the model?
Depends on what odds I'm getting. I need to do a loss function and see how my expectation and variability is, and how much risk I have. Sorry for boring answer. It's always that. Then I would have to reformulate my question, but I'm never gonna bother.
Okay. And did I get this right now, that you only did it for one party?
No, it was just an example. We do it for all parties.
For all parties.
Jointly.
And so, and does the industry bias change from party to party?
Yes.
And it's biggest with the Sweden Democrats?
I actually think it depends between different elections, right? So I think last election, I think our estimates was that the Social Democrats had the largest industry bias. So I think it was, I don't remember exactly, but 2 or 3% above the swarm of the opinion polls.
Yeah, cool. Thanks.
Yeah.
Thank you. Further questions? So one thing you can follow up on when you start talking about betting. I mean, I know Nate Silver. He started actually not with predicting elections. He started with baseball, if I remember correctly. And is that something you? I mean, have you considered other potential applications except elections here to go into sports, or is it? I mean, what are the sort of contexts in which you can apply the same or analogous kind of models upon? Or is it just elections that you're?
Oh no, I mean, if you look at the states-based model, I think it was invented for what was it?
The moon
Moon landing.
Yeah.
so we we are not the first to use this. It's used everywhere in the different settings. So, and we ourselves use it for different types of problems also.
No, but I meant your interest. Would you be developing this in different directions? So you are interested in elections, and that's what you.
I have no interest at the moment, at least, developing the sports, and unlikely I will do that.
Yeah,
Okay.
no, not for me neither. I mean, this is since it's close to my research. That's what.
Good.
My name is Hanna Brada, and I'm a journalist, so I'm interested in everything. So I wonder, when it comes to very atypical events like pandemic or a war or things like that, does that destroy your model, or do you count on that? Or I missed the beginning.
We do not, unfortunately, take this into account. It's something that we would like to do. We have no idea how to do it. Probably is that you can. I mean, for instance, that's a very good point, because if you look now with the war, with it's appeared that it's favoring the sitting party, but we don't know how to quantify this, so we can't put it in. But potentially in the future, it's something that we would like to be able to do. Maybe, and this is sort of why we try to be transparent and open with the code, that if somebody knows how to do it, then can take it and use that, and also analyze it afterwards. You remember, if we looked at the Vänsterpartiet, we can use it to analyze this. Was it this that happened? Was it this effect? To try to make it quantifiable. But, I mean, it actually is a weakness. Of course, the more instability and how more the changes things from the past, the worse the less we know, and the less we trust our model. That's for sure.
But when the atypical gets more typical.
yeah. I mean, then hopefully that's stabilized and everything is typical all the time, and then eventually the model will catch on. but not now.
But I think it's a really good question, and I think, to me, it has this industry effects that all polls can be off. What was kind of atypical to me, at least, and I mean, we don't know exactly why we see that kind of pattern in the data, but it is something that, if you look in other countries, you see similar effects, so to say, and that, in a way, if you would just go, I don't know, 4 or 5 elections back, that would be very rare that you could see this kind of large shifts. So if there's a very atypical thing that happens just this election that hasn't happened before, then we would never capture that.
Thank you. Next is Tim.
Yeah, so I also had a question about the generality of the model. So when you said that when you do the historical analysis part, what you do is first you start with a model, and then you have some data, and then you sort of see how well the model would have done given the past data. If it does a bad job, then you tinker, then you sort of like go back, and you have this kind of process. I'm just wondering, so for the data that you include, are you trying to have build a general model that will apply across many different contexts and elections, or is it sort of designed specifically for the Swedish context or certain elections?
I mean, we could sort of theoretically, right now it's built only on Swedish. I mean, we run it on other countries, but we don't do it jointly. So we're not borrowing information from Germany to Sweden. Theoretically probably will never happen because it's too complicated, and the inference part will just explode in computational complexity.
Yeah.
It's something like we would like to do.
Yeah.
But
Yeah.
yeah.
I was just thinking that if you tried to do it across countries, maybe the historical part would get a bit tricky because there could be like parochial, like special considerations for this country's history versus that
Yeah,
country's
exactly. We
history.
would really need to sort of look into these things, because if you just apply the model and think that all countries are the same, I think it will just get rubbish.
Yeah.
Thanks. Joseph, again.
Yeah, I had a question about the industry bias. So do you have any clue why this is the case? And do you find systematic patterns of different polling institutions favoring different parties with the surplus? I'm asking this because at least in other countries, in continental countries, there's always an assumption that certain polling institutes give a slight surplus in political coloring to certain parties. Yeah.
So this is a question of two things. So it's first it's the house bias, that's each individual polling. That's what Jonas showed a little bit. But those numbers are also we need to include the industry bias also. But it's like the house bias in relationship to the industry bias. But the industry bias the problem there is that we have so little data, right? We just have 2 or 3 elections in Sweden. You can see the same patterns in other countries. But in general, I think it's hard to know exactly what is going on there. I mean, there are different hypotheses you could have. Like one thing would be that, people just change what they vote for at the actual election day, right? That could be a theoretical explanation. But another thing but now I'm a survey, this coming from the survey methodological perspective. What I think is going on is that you probably have non-response effects. So the people that actually are part of the polling institution or like answer political polls today in Sweden, like in most countries, Statistics Sweden, that's like it's a really, really good survey. They do a really, really good job, but they still have a 50% respondents rate. And the problem is since we're looking at political parties on like such a small, we care about a couple of percentage in different directions. And so it's like a tiny difference. So even if the effect of the non-response is not super large, but say that and this is not rocket science, but you could guess that people that answer political polls, they are slightly more interested in politics than people that doesn't respond to the polls. And that would probably give you an effect if people that are more politically interested also would vote in a different way, right? So my hypothesis is that this is essentially this non-response effect that we have in the polls. And that, I think, has changed quite dramatically over the last 20 years. So if you go back in history, you have much higher response rates, especially like a lot of these really big polls.
And can you tell us a little bit about the future of this type of data on which basically all social science or 80% builds, which gets worse and worse and worse?
That's a little bit why I think this is important as a statistician, right? So that's why I think what we do is a way to see how can we start to capture these effects. Can we try to correct for it somehow? Can we try to isolate it somehow? And that's why I also think that this political parties is kind of a good thing, because we get the truth, right? Every 4 years. So it's a good way to start to look into this, survey errors, essentially, the error structures in the surveys. And I hope that could also help in social sciences, where you actually also use surveys to see if that can help in those settings as well. I have no idea when we will get there, but I hope. That's why I think this is important. Essentially, what we do.
Great, thanks.
So Karim, you have a question.
Yeah, thank you. So yeah, thanks for a great talk. This connects to what Joseph was asking about the assumption here is that large shifts don't the large shifts we see from the polling and then the election result, that is a result of bias rather than huge shifts in behavior. So are there any is there any kind of research on this, or are there any kind of other theoretical reasons to believe that it is in fact a bias and not the behavior of people?
I mean, if we can't actually from this data say that.
Right.
We can't say that on the day that people's behavior fundamentally has not changed, or is it, we do not. I mean, we believe that it is due to the effects that Måns just described, but we cannot from this data verify that.
But is there any other research that can lend support to that hypothesis, or that you could appeal to?
If one wants to sort of push down that this is the effect, I think looking at these exit polls, for instance, would be something that we should do. Because if we see that, for instance, the signs of the exit polls differ in the same way as this the industry bias, it would indicate that it's not a change of behavior. But of course, then you can sort of put another hypothetical layer on that and destroy that hypothesis. But that is something that I haven't thought about that, but I think that's something, if you want to verify which is it psychological or is it the industry effect, that's one thing where I would look, but I don't know any literature.
But I suppose that if you're in your data can observe sudden shifts in the polling numbers, and perhaps there's an external event that seems plausible to explain that, then that would suggest that the sudden shifts are not that strange. I mean, I'm thinking about the famous documentary about the Moderaterna in the election of 2002, when they had a hidden camera and showed that they were saying all these racist things. I don't know if you can see that in the polling before the elections,
you see that very clearly.
Yeah, so that suggests that events like that can actually shift
the polls. Yes, those events can, but it wouldn't answer the question is, do people all of a sudden change their mind on election day? It still doesn't answer that. But yes, in the data you can clearly see that in polls how they went.
Thank you.
Right, further questions?
One.
Yeah, Moa. You have a microphone here.
Thank you. This was really interesting. So I have a question about election campaigns and the precision of these polls and your model as well, because I guess small parties like, for instance, the Liberal Party and Miljöpartiet, they might hope that, we're below the threshold now, but as soon as the election starts, that we will be more visible and maybe things will change. It's of course depressing for them to see that. I think today in the recent poll it says that neither of these two parties are the second choice of almost anyone. So they have a small chance of, people, when people change their mind, it's not going to be for the benefit of them. But they might hope that, once the election campaign starts, we will be more visible and everything will change. Do you see more change or do you in the election campaigns as compared to other periods?
So we see this in two ways. So this has actually been one of the struggles for me to actually get this well. And what we see is, first of all, that the movement of this smaller party increases a lot during the election period. So it's much more uncertain where they will end up compared to where they are. in a way. So they have a much larger movement. So that's the first aspect. The second is that, and I realized that was not part of the structural model, but we also have this.
All right.
This where we try to estimate exactly this effect. So, is it so that the smaller parties, increase, so to say, in the end of the period? And we actually have that as a covariate in the model that we estimate, and we can see that there are these effects that smaller parties, at least historically, if you go back to 1973, you see these effects on these smaller parties. So that is actually part of the structural model that it pushes up smaller parties.
Yeah,
in the predictions.
Yeah,
so it's essentially exactly what you say.
That's a bit embarrassing that I forgot to add that we actually had. Sorry about that. But something also that I didn't know, that nobody says that they are a second party, and this is sort of, that's really why we want to have this. We have this information and we don't know how to use it. This is something that we would like to incorporate into the models, which you can't. Which it would be very interesting if we could say that either that this second part doesn't matter, or that's a really strong sign that something happened. And unfortunately, at the moment, we cannot do that. But it's something that we actually really want to be able to do.
Thank you.
So, further questions? Right, I think I give another shot. I have two different questions actually, and one is sort of more speculative thing. I mean, how accurate can these models be? What is the upper limit of the accuracy of this kind of model for predicting elections? I'm thinking here about, I don't know if you read Isaac Asimov's novel or short story Franchise from 1950s. He's imagining there in his science fiction story, but he's imagining there in electronic democracy, where voting behavior is perfectly predicted by this multivac supercomputer. So actually, no elections are needed, because all the data that you need is gathered by that computer, and there's just a symbolic vote by one single citizen that sort of just confirms that there is some human interference with the election result. What I mean, of course, that was a science fiction story, but how far could these models be developed into actually predicting with really, well, you know what I'm asking for. Then my other question is about the effects of polling and these kinds of models on public opinion and electoral results. You mentioned before that the electoral result works as a kind of truth here. That's the basis for calibrating the biases of the polls and so forth. But of course, the election results isn't perfectly independent of the polls, as we know, because people are somehow affected by them due to bandwagon effects and so forth, and there are contrary effects as well. And indeed, if your bot would be very influential, if you would be hugely successful with your in your applications of this, and it was very good, worked very well. Well, actually, people would be taking your bot and your results into account when they actually voted. And how would that then feed back into the accuracy of your model? Would that be sort of a good thing or a bad thing for developing your model?
It would be. Then it would be go into the game theoretical building of a model. But I mean, in some sense, I mean, we're nowhere near predicting things. And if our model says that it's 60-40 now, I mean, that would be just an encouragement to vote if you have an opinion, right? Because it's so far from certain, like it's a toss-up either way. So So in some sense that is a positive thing. But regarding your first question, how good can the predictions be? That's a very interesting question, and something that we can't answer. But in some sense, it goes back to this: what is changing? Is it people minds that are changing, or is it the polls that are shifting? Right? If we can't decipher that variability, we can't decipher that, because if it's people changing, and we can't predict anything. The polls we could get better. So it's very far from, and you would need a completely other sort of almost forensic model to predict that on that level of accuracy?
Yeah, I mean, I think the biggest contribution that we are coming with here is essentially the uncertainty, right? That is telling the story that, you know, there is a lot of uncertainty in where the election will end up, and try to quantify that in a more formal way. So, and I also, I mean, I find that a really difficult question, how good you could predict this. I mean, the problem now, I think, is that we have this non-response rate problem, I think, that makes it, you know, it makes it even more uncertain, right? So I don't know, but I think this is like what we're doing now is trying to get the baseline model there, to try to calibrate it well with respect to the uncertainty. And then we can try to improve on that model further on.
I would say that if you had perfect sort of all the relevant information, you could do much better than we do.
Yeah.
Then the question is, how good can you do? That's an interesting research question.
Yeah.
Right. Thank you, Jens, Måns, and Jonas, for coming here today and talking to us. And before we end the session, I will just announce the coming research seminars at the Institute. And June 15th, we have Matt Adler talking about person-affecting consequentialism, equity regarding desert, neutral, and repugnant. And June 22nd, we have Janine Vedel from In-House on topic to be announced. So thank you for coming here.